Today we are going to be working on this physics problem. If I throw a rock at an upwards angle of 30 degrees from the edge of the 100-meter cliff and with an initial velocity of 8.5 meters per second, how long is the rock in the air and how far from the cliff will it land? The equations we will be using today are x displacement equals velocity initial times time plus 1/2 acceleration time squared. Cosine theta, which is the angle, equals the x component over the hypotenuse, and sine theta, which is the angle, equals the y component over hypotenuse. Before we answer the problem, we need to make our horizontal component and vertical component charts. We can fill in our known values for both. On the horizontal side, we know that acceleration is 0 meters per second squared. And on the vertical side, we know acceleration is negative 9.8 meters per second squared. We also know that the displacement is 100 meters because it is given in the question. Before we actually start solving for the questions, we need to draw a diagram of the problem. We have a person throwing a rock at 30 degrees upwards at 8.5 meters per second as their initial velocity at the edge of a 100-meter cliff. To the right of our diagram, we split up our angle into our x and y components. To solve for our x component, you use the equation cosine theta equals x over our hypotenuse. To solve, you add in your 30 degrees into the theta and your 8.5 meters per second into the hypotenuse. You then get 7.36 meters per second for your x component. To solve for your y component, you add in 30 degrees into your theta and 8.5 meters per second into your hypotenuse. You then get 4.2 meters per second for your y component. To solve for the time, to answer the question, how long will the rock be in the air, you must use the x to your displacement equals velocity initial for the vertical component times t, your time, plus 1/2 half acceleration time squared. To solve for this, we used the displacement, which is given to us 100 meters, and solved for t, the time. For t, 4.97 seconds. Next, to answer the question, how far away from the cliff will the rock land, you use the same equation that we used for time, but your acceleration is 0 for the horizontal. You can completely cross off that half of the equation because 0 would cancel out everything. Your equation is now displacement equals velocity initial times time. Your horizontal displacement is 36.6 meters. We can now go back to our horizontal and vertical component chart and fill in the velocity initial, velocity final, displacement, and time for both sides. Your velocity initial is 7.36 meters per second. Your velocity final is also 7.36 meters per second because the horizontal velocities are constant. This is because when you split up your rock into the horizontal and vertical components, the horizontal stays the same throughout the rock's entire trip. We can also fill in the displacement for horizontal is 36.6 meters. We found this using our x and y components as well as our time. For the vertical side, you can fill in your velocity initial as 4.25 meters per second and your velocity final as negative 4.25 meters per second. They are opposites of each other because at the beginning of the problem, the rock is traveling with a vertical component going up. As it reaches its maximum height, the velocity is 0, and as it starts to descend its way down, the rock's final velocity is going downwards, so it is negative. The time for both is 4.97 seconds, as that is the total time the rock is in the air. So, for our solution, the rock was in the air for 4.97 seconds, and the rock landed 36.6 meters from the cliff.
Thank you for watching my physics video. I hope you enjoyed it.